Welcome, everyone. I want to give you a sneak peek into future-proof electronics this afternoon. And we want to take a look at state-of-the-art development strategies for embedded vision hardware. So my name is Oliver Helzle, and I'm the CEO of HEMA Electronics, south of Germany in Aalen. To give you an idea of what I want to talk about, I picked one of typical scenarios for mobile vision electronics, typical application with the meaning of there's a system, there's an environment. We have picked the logistics topic, there's transportation vehicles, factory automation. So we have in the surrounding, our embedded vision system has to solve many tasks and has to solve many requirements. So when you think about the vehicle that you can see there, it has a lot of tasks to solve, like avoiding crashes. It has to find its goods to deliver. It has to navigate. At the same time, it has to detect people and objects, to avoid collisions. Maybe it even has to collaborate with other vehicles out there. And when you think about a scenario like this, representing a lot of other applications, you see there's a lot of things to do and a lot of sensors integrated in this environment. So typically, our system consists of several sensors, could be optical sensors, vision sensors, could be a different spectrum of visual sensors, but it could be even things like radar or LiDAR. So when we think about building a vision system, we have a lot of requirements that come out of the situation. We have different sensors, and the big problem there is we have a lot of sensors and components from different manufacturers. There are a lot of German companies that do a great job in building components, sensors, and different kind of technologies. But at the end, one has to integrate all these different sensors to build the system solving the solution. So more often than not, it's the problem that is no out-of-the-box solution, because when you combine different sensors, different kind of technologies from different manufacturers, you have to put the pieces together and have to do a lot of things on hardware and software. So the idea and the ultimate goal is to build a system, a hardware system and software, to combine all these informations, to rework these informations, and to deliver the solutions, the informations that are needed for the people or the systems that have to interact in this scenario. And of course, you never have enough time to do it all by yourself. Many thanks to the other speakers for the last hour, because a lot of topics are already told and presented concerning cameras, concerning software, IP cores, and how to design and how to use them building a system. So when we focus now on building hardware solutions, we can use all these informations to put it together in our head and build a picture how this could work out. So when you look at the three-layer topic, the picture in the middle, we talk about the lower level, it's the hardware level. We have a medium level, we call the IP core level. You had a talk, half an hour about IP core, so you know what is done there. And then we have the upper layer, it's the application, and the application is that what is seen and what the user is handling and what is doing for the logistics topic, for example. There's the application of finding the right goods in the right place and to the storage, to the navigation. So we built the system, roughly speaking, with three layers with different tasks to do. Okay, just a second, picking the next slide. Usually, development teams and designers go into action and pick all the components. Let's get all the components we need. Sometimes we don't know which one we will finally use, but we get the components, we stick them together, and make it work somehow. So the picture, of course, it's okay if you take a smile, because yeah, sometimes it looks like this. Sometimes I think it's more professional, but to show you the problem that we have to solve there is that at the beginning, it's quite experimental what we do. And the question is, does it really help? Is it that what we want to, and is it a good approach? And what of these systems, even if they solve the solution, the task, and they are helpful, none of it is reusable. And of course, none is production ready. So if we solve it like this, we give out this to our colleagues in software and design, have a lot to do now, and maybe later on they have to do it again. So we at HEMA thought about better ways, and we developed a hardware design system that makes the prototyping more easy, fast, and industrial ready as possible. So we call it the solution we present today. The topic of my presentation today is the embedded vision platform. So far, that means that we build a design kit for customer-specific industrial mainboards using mainboards and FPGA SOMs that will provide a close to serious prototype in a very fast time. So we get the requirements from the scenario, think about the logistics topic I talked about. We have to integrate all these sensors, build the hardware. And at the beginning of our development phase, we have to stick it all together. So what else could we do than just using test boards? So we said, okay, let's build a platform, a kind of toolbox where we can put different components together and build a production-ready, reusable first board. And normally we can do this using the FPGA SOM technology we already discussed. We can do this in 6 weeks. Just a second. I have to arrange my screens here. This all begins when at the beginning, when you think about the systems design, you go through all the options. Everybody has some wishes. We have this kind of sensor. We need this interface. We have lots of megabytes and gigabytes of resolution and bandwidth. And we define the system, what's coming in from cameras and sensors, what we have to deliver on the output side. Is it a technology solution? So we have to get some more information. Is there what kind of software and application, maybe artificial intelligence, is built on top of the video and the informations we get from all these sensors? So we thought about how to build a configurator. Yeah, so it's not a new topic, but here you can see how it works. You say, okay, I need 2 cameras, 3 interfaces. I need gigabit Ethernet. I need analog or digital inputs. I want to use an FPGA, for example. There we have the Enclostra SOM boards or the new boards from the KRIA, from Xilinx themselves. And then you calculate and you should look at your system, what you need and how you want to build it up. So, at this point, you can find this configurator on our website. And if you like to play with it, to use it, just feel free to go there and have a try. So the next step, we designed, roughly we have a building blocks, a library with 45 building blocks. And the list is, of course, continually being extended with the projects that come in and the new interfaces we put there. So when you look there, many of them you can already recognize. You know them, and you see, okay, there's sensor input, output, different interfaces that are typically used in these embedded vision projects. The blocks are predefined. We have built all the schematics and the layout elements. And when you think about a puzzle game, you can see how this could work. So you pick the options, take the elements from schematics and layout, and then it's really fast to put these together and build your own combination of these main boards. And what we did next, we not only defined the building blocks, we even bought the components, because we have reused a lot of components from project to project. We already put most of them in stock in Aalen, so that we can not only have a fast design cycle, but also can build these main boards as fast as possible. Of course, today, not everything is available. Yeah, sometimes you hear say, okay, I need an FPGA, yeah, it will take maybe 50 or 60 weeks. So to handle this, we put a lot of stuff in stock. Of course, not everything that is obtainable out there, but we even bought the SOMs, the FPGA board modules, to have some of them in stock, to build prototypes, and to help all your engineers to have a easy and fast start into the project. Because the faster we begin, the earlier we can go into designing and programming software, sooner we can go to the market and show our products. Well, after a few days of work, you can see the system looks like this. Yeah, most of the blocks are out of the toolbox. Many of them are used in many projects we already did of the last couple of years. And of course, sometimes there is a new one, might be an orange one, who said, okay, there is something new, or there is something that you have specially for your applications, what makes it exclusive for you. So there could be 10–20% of these boards may be exclusive or brand new. So we will have to do the design check on this and put it into these designs. And as soon as the customer is satisfied, you see the results, we go into production. And an important point is that we have our own PCB production, so we can go right after the finalized and design, we can go into production here at our company in Aalen. And when you look at the way that your design goes, the design flow is, the schematics, the layout is done, and the prototyping, we can go down to 6 weeks for the whole design cycle. Sum it up. You see one of the pictures. It's the world's first KRIA mainboard we did in the beginning of the year. We picked the Xilinx KRIA, and I said, okay, let's see how fast we can do it. And it was not 6 weeks, it was 7 weeks, but we could tell that we have finalized and produced the first mainboard for the KRIA SOM in June when we presented it. So what is important about this, that we can speed up the design process. We can reduce the complexity of the systems. We heard earlier about the complexity of building the hardware system, the software system, the IP cores. All this is part of the design process when we talk about high-end embedded vision electronics. And of course, the benefit is the sooner we get into the project, the faster we can go to the market. We call it Fastlane. So we built a process in our company with, we aligned the design, the production, the components in our logistics, so that we can build all this under one roof here in Aalen. So our engineers go to the production people and discuss how can we design the boards, how can we do the layout to have a smooth flow through all these different departments. And of course, if it's under one roof, you just have to walk some 10 meters to your colleagues. It's quite easy to have a simultaneous engineering process in-house and build these main boards. So what we do for 43 years now here at HEMA is electronics design, hardware design, software design, and production. And for these many years, we have the expertise in a lot of areas, of course, industrial applications, medical applications, security applications, just to name a few of them. And we have seen over the last 25 years of vision electronics that it's important to focus on these kind of applications and to help our customers to accelerate the design processes, to keep up with the growing complexity and the many applications, different applications that are out there. Many of these skills you see there are typical for engineering, electronics development, electronics manufacturing, and of course service. What is important for us to have the skills to support our customers from idea to life cycle support. So we can go into the design and in the concept phase with your team, talk about the architecture, how to build a system, how to pick the components, how to configure, depending on, is it a smart edge device or is it a more centralized application, how to best build the architecture, and to put 25 years of embedded vision knowledge into the design flow that you have with your team. And depending on what task is at hand, we help you with these skills, even on the one hand, the whole team, or the skills that you need, or the single tasks that help you most, where you don't have enough people in your company, or you have a lack of information or knowledge that we can keep up and bring to your project. The technologies we use are, of course, FPGAs. We use a lot of FPGAs, especially from Xilinx. It's the main technology we use for our embedded vision systems. And it was a nice move there when we heard about the release of the KRIA SOM. We had said, okay, that could be a really interesting SOM to be integrated into these industrial vision systems. And so we said, okay, let's make a run for the KRIA. And as I told you earlier, we built this mainboard to show how the processes work, how we at hema work, and how does it function, uses this technology. And there's a lot to talk about Xilinx KRIA, but that should be done on another occasion. So far for today. Another technology we use, or technology, it's the already mentioned Enclosure people from Zurich, from Switzerland. They have a broad range of modules, and they are experts in building reliable modules that are proven for many years. And we did a lot of designs, some with one FPGA, some with even two FPGAs on one board, to make special applications, for example, in security or medical applications. And we have quite a long history and expertise in using these SOMs. And SOMs give us a lot of options and possibilities to scale the systems that we build. Now there's still one topic not addressed so far. How are the designs future-proof? So we talked about defining a system, designing the system, but the option is there, what is future-proof? What is meant by future-proof? You remember the picture where we used a lot of test boards to make a mock-up to have our first tests. And we say that it's easier to build a first industrial grade board with our design system. And of course, at the beginning, often you don't know what will you need at the end of the design process, or maybe after testing, there will be some people that say, okay, if we could do these changes or integrate this interface, there would be many more customers that we can address. So there comes the second interesting option. So we use the main board and the SOM on top of it, and we can scale and tweak the system. For example, when you pick one of the other sub-modules out of the product range, for example, from Enclosure, you can scale your processing power. You can enlarge processing power because you have more IP cores to integrate or more sensor data you want to integrate. Or even you can scale down if you see, okay, the testing board we put all in, and now we want to go to market prices and scale down with an FPGA. That's one of the options. The other option is that you can take the main board, you take the main board off, you change the main board. For example, yeah, we want to have a MIPI interface, or we want to have 4 instead of 2 SDI inputs. So we just take the main board, make the changes to the main board, we refit the FPGA on top of it, the software and all the things you did for your application, IP cores, we can put on top of the main board again. And with some minimal adoptions, we can enlarge the interfaces and options that is the main board and the whole system with the SOM can do, and the options we have there. So you can scale down, you can scale up, you can adopt to the growing and expanding design of the system and the final application you want to do. And of course, if you have to go through a design cycle for the main boards, it's 6 weeks again. So it's not that complicated. And during testing, 6 weeks, when you think about projects going from 6 to 12 months, it's okay. It's an okay time. So shrinking down from 24 weeks to 6 weeks, that's what we want to bring here in the discussion for the design of the systems. And of course, the goal is for us to get you ahead of competition, to be the first. And while we had a discussion about how to build future-proof systems, the people at hema delivered the next system to a happy customer. So we have here our guy again, and we just delivered the next mainboard out there to one of the happy customers that can work on their system and being the first to market. It's our mission. And at this point, I want to thank you for listening to me, to see what hema is doing and to show you interest. And now we look forward to some questions and the next round of discussion we have together here. Thank you very much.